Hi students, good morning. Welcome to this video session. My name is Samuel Dominic Chukwu Emeka, aka Sam Dom for Peace. In this video session, we shall discuss measurements and units. And the title of this session is Give Me the Lotion. How many units do you see? So this is a project that you can do with your students. You may call it a PBL, project-based learning. When you are teaching your students conversion of units from the metric system to the customary system, or from the customary system to the metric system. The metric system is the international system of units, while the customary system is the United States system of units. You may just ask your students, okay, what do you see around you? What do you have? Do you have a water bottle? Okay, check the container. How many units do you see there? Do you have a lotion? Check the container. How many units do you see? Do you have a hand sanitizer? Everyone is encouraged to use hand sanitizer or wash your hands. Check the container. How many units do you see? Do you have a soap to wash your hands? Can you see the packet of the soap container? Check it. How many units do you see? So they can start with one unit and then convert to the other unit. Typically, they will see 2 units. Sometimes they will see 3. But the units are of 2 systems. The metric system, which is the international system, and the customary system, which is the United States system. So they can start with the unit in the metric system and then convert to the unit in the customary system. And then check the calculations to make sure that the answer they get is the same answer that is on the container. Or they can start with the customary system, the unit in the customary system, and convert to the unit in the metric system. So let us look at some examples. To access the website for this presentation, you can get on my website. You can use, you can access it, okay, samuelchukwuemeka.com, or you can also use the secured form with the HTTPS. Either way, you can access it. So I just put it here. I typed it in Microsoft Word, and as you can see it, or you can also go to chukwuemekasamuel.com. So any of these websites will work. Okay. So let's go ahead, and I'm going to press Control plus click, Control, and then I click it so I can get on the website. And once you're on my website, you click on mathematics, and you click on arithmetic. This topic is for students that are learning conversion. You can also use this topic for students that are learning dimensional analysis in physics. This topic is also beneficial to them because of the methods that they can use. We typically use 2 methods. We can use more methods to solve problems in measurements and units. This is under measurements and units. Okay, so but this topic, this is not only measurements and unit. Once you get on this, just click on project. So this topic is not just for measurements and units. Students that are learning dimensional analysis in physics, this is helpful. Students that are learning proportions in algebra, this is also useful. Elementary students that are learning conversions, this is very helpful. And even middle school students and even high school students, anything that deals with conversion of units or deals with conversion of variables, for conversion from one unit to another, this topic is helpful because of the methods that you can use to do the conversion. Okay, so this is not only limited for just learning a conversion of units between customary system and metric system. The method used in the conversion is the most important thing that you really want your students to understand and learn. So I give this project to my students when I teach them conversions or proportions or proportional reasoning, or even fractions, because with fractions we still deal with proportional reasoning. So and I only give them 3 tables, only 3 tables that they can use. They cannot use any other source, but I only give them 3 tables: metric to metric conversions, customary to customary conversions. This is the United States. This is international. When we say metric is international, we say customary is United States. Customary to customary conversions, and then metric to customary conversions. So these are only the 3 tables that I give them because of what I want them to learn. I want them to learn the unit fraction method and the proportional reasoning method. These are 2 methods, typically 2 methods we use to convert for anything, okay? Not just conversion of units between systems, no. We use it to convert we do use it for any conversion. If you go to solve the examples, all measurements and conversions, you will see how we used it to do a lot of questions. Okay, it must not be only conversion of units between systems. It could be conversion of currency, as you can see here. Okay, conversion of currency. Anything that deals with conversion this topic helps a lot for them. All right, so let's look at some examples here, and you can go over this. These are just the rules I give to my students on how they can do the projects. Usually you want to specify the containers you will allow. You don't want a student to use container of alcohol, no, because we don't want to teach them that. You want them to use just containers of the things they use on a daily basis. Okay? So, and it is important you ask them, why do we have these 2 units? Okay, why don't we just have 1 unit? And this is something that they can find out on their own. The United States of America has not adopted the international system of units because of politics, but they can find it out on their own. It's just for research why they have units. But the main thing that is good for them to know that you might the question you have to ask them, okay, and let them think about it, and provide you with an answer is, why do we have 2 units? Okay, this is a soap bar container. Okay, this is a soap bar container. Why do we have 2 units? Okay, we have in ounce and we have in grams. Why do we have it on the products, on the items sold in stores? So, and you look out for answers, look out for the answers they might have. Like I said, why we have 2 units, why the United States and about 2 other countries have not adopted the international system of units. For United States, it goes a long way to politics. Okay, but why do we have the 2 units on each item? Typically, okay, you look at the pizza, the containers, containers for pizza, for food, for drinks. Any container, when you go to the store, just look at the container, the boxes. You see 2 units for the food, for the drink. Why? So watch out for the answers, because these are questions that should encourage critical thinking for your students. Okay, so some of the answers you have to watch out is for when items are produced in America, in the United States of America, they also want to sell those items in other countries. They want to export the items to other countries. And for them to do that, they have to include the units that that those countries use. Okay, so the United States manufactures items, and they want to sell it in Nigeria. Nigeria, we use a international system, so we don't use ounce, we use grams. Okay, so they have to include grams in the item, in the container of the item. Similarly, like as you can see here, this is moisturizing bath bar, Yardley, London. So looking at it, it looks as if this product is made in London. Okay, and London uses international unit. So if they want to sell it in America, they have to include the American unit, the United States unit, which is based on the customary system, which is ounce. Okay, so 4.25 ounce is the unit in the customary system, and then 120 gram, the ounce is the unit in the customary system, and the gram is the unit in the metric system. So you can ask your student to begin with, to start with 4.25 ounce and then change to gram. And when they finish that, they start with 120 gram and they convert back to ounce. Okay, and each person should do it for each container, and they should have different containers. So first of all, let them work individual projects. Okay, bring different containers of food, drinks, lotion, soap. Then work on your container, and then you go around the classroom and you see what they are doing. I know in this COVID era, you can find how you can do it, or if it's online, they can, you monitor them on what they are doing, the calculations. And when they are done, they can exchange the containers they have. They can exchange the containers they have and work on other one's container. And for the group work, they can also work in groups to work on the container. So this topic can be used for individual projects, group projects, peer learning. It can be used for that as well. Just adapt it the way you want. But it's good to encourage critical thinking questions, to ask questions that encourage critical thinking. All right, so this first example, 4.25 ounce to gram, the first thing we ask ourselves is, you look at the table, this also enables them to review tables. So you ask the question, do you find any direct conversion from ounce to gram? Okay, when you look at the table, ounce to gram, so you come to this table here, metric to customary conversion. Ounce to gram or gram to ounce, it could be either way. Okay, so the first question you ask them is there any direct conversion from ounce to gram or from gram to ounce in the table you gave them? Okay, I don't see it here. Okay, there is no direct conversion from ounce to gram or from gram to ounce. So, and like I said, they have to use only this table, only, because you want to teach them the concept of using unit fraction method or using proportional reasoning method. So, since there is no direct conversion from ounce to gram or from gram to ounce, what do you now see? We have a direct conversion from gram to pound. Okay, that is what we have. We have a direct conversion from gram to pound. Okay, the next question will be, is there any direct conversion from ounce to pound? So look at it here. The first question you ask them is there any direct conversion from ounce to gram or from gram to ounce? Okay, so we see, based on the table you gave them, there is none. Okay, like I said, you don't want them to use, you want them to use only this table. You don't want them to go and go to online and type in gram to ounce. No, it defeats the purpose. It defeats the purpose. Yeah, you don't want them to go to online or use a table that has gram to ounce. It defeats the purpose. Okay, the purpose is for them to learn how to use that method, unit fraction method, or proportional reasoning method. So, and also to use the table, use what you have, use only the tables you have, and make connections. Make connections. So we don't have, no, we don't have. Now, but we do have. Now, what do we have? What do you have? What do you have? So we have direct conversion from gram to pound. So the next thing you ask them is there any direct conversion from ounce to pound or from pound to ounce? Okay? Any direct conversion from ounce to pound or from pound to ounce, because you want to make that relationship. Okay, and as we see, we look at the table now. This is now customary to customary, because pound is customary, ounce is customary. So we have that 1 pound is 16 ounce. Okay, you see that 1 pound is 16 ounce. So we do have that. Okay, now you come and you write, okay, 1 pound is 16 ounce. And also 1 pound, as we can see here, 1 pound, as we can see here, is 453.59237 gram. Now, let me make a note here. These are the exact, not approximate. Okay, these are the exact conversions. Okay, this table, that's why I said they have to use this table. We don't want to approximate. We do not want them to use approximate conversions. Let them use the exact conversions, and they should not round any intermediate calculation. They should only round the final answer. Only the final answer. Okay, they should not round intermediate calculation. They should only round the final answer. So we see that 1 pound is 16 ounces. We also see that 1 pound is 453.59237 gram. So 1 pound is equal to 1 pound. So we can use proportional reasoning method. Okay? With proportional reasoning, you ask them this. What are the 2 units involved? See, it's ounce and gram. Okay? Because 1 pound is equal to 1 pound, we now see that 16 ounce is 453.59237 gram. So what 2 units are we talking about now? Ounce and gram. Okay, and that is what we want to have here. 4.25 ounce to gram. So we put ounce and gram. The first line, we now put 16 ounce because this 16 ounce is equivalent to 453.59237 gram. Therefore, 4.25 ounce, what will it be? So we put 4.25, and that is where you now start introducing elementary school students to algebra. So the issue is some students do very well in elementary school, 1st grade, 2nd grade, 3rd grade, 4th grade, 5th grade, mathematics, they do very well. When they now get to 7th grade and they begin to see variables, A, B, C, D, E, F, X, Y. So if they don't have, you need that to just explain to them, hey, this is just a placeholder, a variable. Okay? They ask you, what is P? Tell them, okay, it's something we don't know. It's an unknown. So this is a good time now to begin to introduce elementary school students to algebra, to variables, that whatever you don't know in mathematics, just use something like a placeholder. Call it anything you want. Okay, and the easiest thing we can call it is to use alphabets, English language alphabets, which we now call variables, to hold it, because we don't know what it is. They ask you, what is X? Say, it's something that we don't know. It's an unknown. It is what we want to find out. So we just say P. You can use K, you can use G, you can use any alphabet you like. Okay. Now we do the proportional reasoning. Okay. We can do P, and you ask students to now form proportions. If you're teaching fractions and proportions, fractions, then ratio, then proportion, because proportion is the quality of 2 ratios. This is a good time to ask them, how many ways can we form a proportion here? So we can say P over 4.25 is equal to 453.59237 over 16. That is one way. We can say P over 453.59237 is equal to 4.25 over 16. We can say 4.25 over P equal to 16 over 0.59237. We can say 4.25 over 16 equal to P over 453.59237. So many ways. I think I said 4 ways. No, it's more than 4 ways. So many ways they can form a proportion. Just make sure that it is proportional. Okay, they can say 453.59237 over P equal to 16 over 4.25. Okay, so now this is the proportion, and that is why we call it proportional reasoning. We ask ourselves, what two variables are involved? What two units? I mean, what are the two units involved? Ounce and gram. Just like when you ask to convert how many days in 7 weeks. What two variables are involved? Days and weeks. How many hours in 3 days? What two variables are involved? Hours and days. Okay, and that is the when you have two units, you can convert from any unit to any unit to any unit. Okay, just ask yourself what two variables are involved. Then you write it. Then you write the main conversion. Then you now write the what you want to convert. Okay, after doing that, you set it up as a proportion, and then you do cross product. You can do cross product. Normally, I like to you want to isolate P. Okay, I know there are several ways you teach equations, and the main thing is to teach it in a way, whichever method the student understands. Some prefer cross product. Some will prefer multiplying by the multiplicative inverse. Okay, by the multiplicative inverse. So multiplying both sides by 4.25 crosses out. So you now have only P. You isolate P, and you get it. 120.485473 before you now round the final answer. You want to make sure that you see this intermediate calculation. You really want to make sure that you say it. You really do. Okay, before they now round the final answer, and that gives us 120 grams. This the other method is unit fraction method, but I was asked to keep this video under 30 minutes. I don't want to. I want to stick to time. Please go over it. I think I explained it well. If you have any questions, feel free to contact me. And we are in this together. We want the best for our students. Please stay strong, stay safe. I wish you the best. Have a great year.